Hey everyone, my name is Bob Argenbright. I work at Heroku. So we had a problem, sometimes it's a problem, where you need to figure out the best architecture for your application, right? We all have to go through that design phase. And one of the things we wanted to do was have a simple way to be able to extend our application and have other junior devs involved in the application development and have an easy way to kind of guide them to that. And also have to not re-architect our application every time we wanted to add a new feature, right? So the thing everyone does is go to plugins because it's a solid architecture for doing that. So one of the reasons we chose plugins, and as developers we usually choose that plugin architecture, is like I said, being able to extend your application, extensibility. We don't want to have to re-architect the whole code base every time we have to add a new feature. Simplicity, so that everyone understands there's a small piece that fits into a bigger puzzle. Reliability, you have a simple, reliable API that you can document and show other people how to add new features. And then approachability, like I said, for junior developers and even people who are, if you have open source projects, external developers, third-party developers who want to add functionality to your app, you can have an easy documentation that shows here's how you add new features. So some simple plugin requirements, you need to be able to load, maybe even unload, run and stop methods that are available within the plugin, and handle errors gracefully so that your small plugin doesn't take down your entire code base. Just some notes on complexity. You can have a single process architecture where everything is actually compiled within the main app. And then you can have a multi-process architecture where you've got your plugins actually running as separate processes. They're monitored on their own, and then they call back into the host process, which helps with troubleshooting when you have an error in your plugin process. Even if you're not handling the errors gracefully, it crashing won't crash your main app. So now let's dig into some example architectures. These are ones that I found through various ways of research. Some I just kind of came up with on my own while we were trying to figure this out. But most of them are documented elsewhere, and other people have implemented in a good fashion. So when I was building this talk, the first thing people would ask me is, are you going to talk about the plugin package that is now in the standard library? So it's in there. It was released in Go 1.8, and currently it's kind of in a beta because it only works on Linux builds. But it's single process. It's pre-compiled as shared object files, and then you can dynamically load it via the plugin package methods. So how you would do that is use the build mode flag and specify that it's a plugin. So here's just a simple example. You can define a simple function like you would in any Go package, and then use those plugin methods to open it and use a lookup to retrieve those symbols, where you can then use it later. Another one I found that was really popular was using RPC. This is obviously a multi-process architecture where you're going to have a client and a listener, and they communicate over RPC. You can have that local or remote, so you can be having your plugins communicate over a local host RPC server. One of the benefits of this is that it's language agnostic. Anything can be on the other side of that RPC connection, and it just has to know how to talk RPC. So if you want to look at some examples, there's Go plugin, which is a library provided by HashiCorp, and then Pi, which is developed by Nate Finch, and both of those use RPC, and Pi even has some examples of using Python to call through that RPC connection. So I went with the name Traditional for this architecture. It's that may be confusing, but to me, I came from an object-oriented design background, and so traditional object-oriented design plugin architectures use like object inheritance, and so trying to do a similar thing in Go obviously doesn't work, but I kind of just carried over the traditional naming because it uses language primitives in a way that's used inside of the standard library, which I feel is kind of the same philosophy of like class and object inheritance. So the benefits of this is that it's just single process, all compiled into the main code base. If you add a new plugin, you just recompile. It's really simple because it uses the main design patterns that are even used in the standard library. So one of the examples of that is the net HTTP library, where we have a handler interface, and what we want to do, our goal is to add handlers to our HTTP server. So having a strict contract that says, here's how you implement a new handler, you can define as many new handlers as you need. So as long as you have a struct that satisfies that, or has a function that receives a handler func, you satisfy that handler interface, and it works just like a plugin. One that I experimented with just because I thought it'd be fun is using goroutines to run multiple plugins. It's simple, single process. It's pretty reliable because it uses the goroutine construction, and it's solid. We can communicate using channels. I would say, though, that this is probably not a good thing to do in production because it's not really how goroutines were designed to work. It works just fine, but doesn't really fit with the Go idioms as far as I feel anyway. But it's just a fun example to look at and kind of theorize about. So we can define a struct that has a run channel, error channel, and a done channel, so you can close it out. And then you have your commands that are available in your plugin package defined in some kind of map or structure. And then you have a run method that receives that plugin and handles the various cases with the for select loop. And then in your plugin package, or wherever you're calling the plugin, you can just load it up and create the new plugin instance using like a new method. You run something like a runner or a plugin manager that would stand up all of your Go routines, and then you can just send messages to it, just like using Go routines anywhere else. And so we created a new plugin. We sent it the GopherCon string, and then we just sent it a done notification. Some other options that I looked at were embedded scripts, which I kind of tend to lean away from, because then you have to have some kind of parser or interpreter inside of your application. And then config files, which if you saw the Kubernetes cops talk over the past couple days, then you would have seen how they were using YAML and how that was kind of a nightmare. And I feel like that's kind of just how it is with config files. You're kind of always pushing the envelope there. So how we finally ended up doing it was we just went with the traditionalist approach. We defined a plugin interface with like a run and a register method. And then you define a struct that implements those methods. And when you're actually calling it, you just create the new struct, run the register method, which puts it into the global loaded plugins map. And then you can use that plugin.run method, and it runs the same way. Really simple, really approachable, especially for junior developers. We can say, like, hey, here's a template. You create a new struct, implement the methods, and they're good to go. And then when you're actually implementing this in production, you just need to have some kind of plugin manager that keeps track of all of them and also handles errors gracefully and all that. Cons are it's a little bit restrictive. You need to make sure that the interface that you define up ahead is able to be adaptable and satisfies all of your needs. Otherwise, you're going to have to be re-architecting that interface multiple times, and then you've just lost all the benefits of your plugin architecture. So here's my recommendations. These are not solid, fast guidelines, but just how I felt when I was going through the research to implement plugins. The plugin package, RPC, and the traditional method are all really good. GoRoutines method, like I said, is kind of hazy. And then embedded scripts and config files, I would just shy away from. Here's some references that I used when I was researching, and you guys can go back through that. The slides will be available on my GitHub after the talk. Thank you.